So here in this video we are going to see the homogeneous differential equation. So first of all we will see what is meant by a homogeneous differential equation and the method to solve the differential equation here. Okay. So what is this homogeneous differential equation? Suppose I have a differential equation like this. Your dy by dx is equal to, okay, I have it as x squared plus y squared divided by x into y. So what is the degree of this numerator actually, or of this polynomial? The degree is nothing but equal to 2. Okay, so here the degree is equal to 2 you get. What is the degree of the denominator? X into y. Here also you have got 1, here also you have got 1. 1 plus 1 is nothing but equal to 2. So what is the degree of the polynomial you get here? It is equal to 2. This is what you have here. Okay. So this only we call it as a homogeneous differential equation. So here if the degree is same throughout, then I can say that it is a homogeneous differential equation. So what is the working rule, or how do you find the particular solution or the general solution for that homogeneous differential equation here? So you've got just two steps here. In this case, the first step is what actually here you will have to check whether it is said to be in homogeneous nature, like how I said, no. So here if you see whether the numerator and the denominator has got the same degree, that is how you will have to do here. Next is what actually here you'll have to make a substitution, that is put y is equal to v into x. So when I put y is equal to v into x, what is your dy by dx equal to here? It's v plus x into dv by dx. Okay, so after substituting this, what will I do here is the next step will be nothing but your variable separable method, what we did in the previous exercise. So here what we did in the previous exercise is what? Your variable separable method. Actually here I'll have to just separate it and then I'll have to find out the solution of this differential equation. Okay, so here it's an important exercise here, then exercise. Okay, so here how do you solve a differential equation if it is said to be homogeneous in nature? Okay, so now here we'll go over to the exercise. So here we'll start with the exercise 9.5. So question number 1 to 10 you'll have to find the the general solution. Okay, and you'll have to check whether it is said to be homogeneous and then you'll have to solve it. Okay, so here we'll go over to the first question. It is x squared plus xy into dy is equal to x squared plus y squared into dx. So first step what I will do here is I will write it as dy by dx equal to. So when I bring this here, you can write it as dy by dx is equal to x squared plus y squared divided by x squared plus xy. Now what is the degree of the numerator here? It's nothing but 2, because both has got power 2 here, so degree is equal to 2. Coming to the denominator, here also degree is 2, here also you have got 1 plus 1, that's nothing but equal to 2. This is what you have here. So how do I write here? Degree of the numerator and the denominator is nothing but 2. Therefore the differential equation is said to be homogeneous in nature. Okay, so this is the first step. First check if it is homogeneous in nature. Now the next step is what actually here you will have to write what is your substitution here. So what will the substitution be? Let y be equal to bx. So your dy by dx is equal to v plus x into dv by dx. This is what you have here. So now substitute it in this equation here. So what is the equation you get? Dy by dx is equal to x squared plus y squared divided by x squared plus xy. So when I substitute it, you will have it as v plus, okay, so here when I differentiate this one, what will I get here? By using the product rule, it's v into 1 plus x into, what will I get here? Dv by dx. Okay, so here these both are nothing but the standard things throughout this exercise. Will be using it here. So substitute it, you will get it as v plus x into dv by dx is equal to, what is the value of x squared? Is nothing but x squared plus y squared. I can write it as vx the whole squared. So when I write it as vx the whole squared, what will you get? It's v squared x squared divided by, it is x squared plus x into y. So what is x into y there? It's x into vx. What is x into vx? It's nothing but vx squared, which is equal to, take x squared common here. It is x squared into 1 plus v squared divided by x squared into 1 plus v. Okay. So here if you see, your x squared and x squared gets cancelled. So you're left with v plus x into dv by dx is equal to 1 plus v squared divided by 1 plus v. This is what you have here. Okay. Now here we'll just, so now here you'll have to do by the variable separable method. So the first step, the second step is over here. Next after that, which is a method I'm using here, the variable separable method. So by the variable separable method, which are the two variables now you have actually here? You've got it in terms of x and v here. Okay. So here we write it as x into dv by dx is equal to 1 plus v square divided by 1 plus v. This comes to the right hand side. So you write it as minus v. Now this is equal to 1 plus v squared. When you cross multiply, it's minus v squared divided by 1 plus v you get here. This gets cancelled. So you're left with x into dv by dx is equal to 1 minus v divided by 1 plus v. Okay. So here we'll just cross multiply, bring all the v terms to one side and the x terms to one side. So how do I write it here actually here? You will have it as 1 plus v by 1 minus v into dv is equal to dx by x. Okay, so I have separated the variables here, v separately and x separately. What's the next step you'll have to do here? I'll have to integrate both sides. So when I integrate both sides, integral of dx by x is equal to integral of 1 plus v by 1 minus v dv. So here this is the one. So now my problem is with integration. So this part I can integrate it directly. I can write it as log x. Here this is what I'll have to integrate it with respect to v. So here you have it as dx by x is equal to, okay, so what is that you had actually here? You had it as a 1 plus v divided by 1 minus v. This is what you had here. So what did I tell you actually here? So if you have it like this, we'll try to bring it to 1 minus v here. So I'm going to add 1 and subtract 1 here. So when I add 1 and subtract 1, this 1 plus 1 is nothing but 2 I have written here, minus 1 plus v of course. So this minus 1 plus v, I can write it as minus of 1 minus v because I want only 1 minus v here. So you write it as 2 minus of 1 minus v divided by 1 minus v dv. This is what you have here. So integral of dx by x is equal to, separate it into two separate parts actually. So when I separate it, what will I get? Integral of 2 by 1 minus v dv minus integral of 1 minus v divided by 1 minus v dv. This is what you have here. So what is integral of dx by x? It's nothing but log x, which is equal to, here if you see, what is integral of 1 by 1 minus v? You will get it as, of course you have 2 years, I have written it as 2 into log mod of 1 minus v divided by the coefficient of v. What is the coefficient of v? It's minus 1. Minus, here of course it gets cancelled, integral of dv is nothing but equal to v. So I will write it as minus v plus log a constant. Got it? So here I've just rewritten it as, in this case I'll just take this to the other side. So it's v plus log mod x. Here again you have minus. When I bring it to the other side, you'll have it as 2 into log mod of 1 minus v, which is equal to log constant. Is it clear? So we have integrated, but my question is in terms of y and x. So the answer also I need it in terms of y and x here. Okay. So initially what was the substitution we did there actually here? Y is equal to vx. So from this you know what is your v equal to. What is your v equal to here? It is equal to y by x, you know here. So I can just substitute v is equal to y by x. Substituting it, you will have it as y by x plus log into mod x plus 2 into log mod of 1 minus y by x, which is equal to log constant. Okay. So y by x plus log mod x plus, what will I have here? This can be written as x minus y divided by x. Here this becomes whole squared. How is that you will get actually here? Your log of m power n. What is log of m power n? Actually here it is equal to n log m. This is what you have here. So using this rule, it becomes whole squared, which is equal to log constant. So I can write it as y by x plus log x plus log of x minus y the whole squared minus, what will I have here? It's log x squared, which is equal to log constant. Okay. So here what will I get? Y by x plus log x plus, here again it's log of x minus the whole y the whole squared. This becomes minus 2 log x, which is equal to log constant. Got it? So here you have it as y by x minus log x. What will you get here? Plus log x minus 2 log x will give me nothing but minus log x plus log of x minus y the whole squared is equal to log constant you get. So what is your y by x? Okay, so here I can use, what is it? Log of m minus log of n. So what is log m minus log n actually here? Log m minus log n is nothing but equal to log of m by n. This is what you have here. So I can write it as log of x minus y the whole square divided by x, which is equal to log c. So how do I write here? Log of x minus y the whole square divided by x. Okay, so here when I bring it to the other side, it becomes minus log c, which is equal to minus y by x. Got it? So here again I have made use of this part here. Log of x minus y the whole square divided by, what will I get here? Cx, which is equal to e minus y by x. Now to eliminate this log, okay, I can take just e power both sides actually here. So you know what is your e power log x. What is your e power log x? It's nothing but equal to x itself. So I can write e power log of x minus y the whole square divided by cx as what? X minus y the whole square divided by cx, which is equal to e power minus y by x. So when I cross multiply, you will have it as x minus y the whole squared is equal to cx into e power minus x. So here this we call it as this is the required solution for this homogeneous differential equation. Is it clear? Okay. So here even after integrating it by the variable separable method, okay, after finding the solution, you will have to simplify this. The simplification part is very, very important. Second question, y dash is equal to x plus y by x. Okay, so here it's given to us directly. So I can check whether it is said to be linear or not. So what is that you have? dy by dx is equal to x plus y by x. So what is the degree of the numerator? It's nothing but 1. Here also you have got 1. Here also you have got 1. What is the degree of the denominator? That is also equal to 1. So the degree of the numerator and the denominator is said to be 1. Therefore the differential equation is said to be homogeneous, I can say here. Okay, so here again, so what will I do here if it is homogeneous? I'll have to solve it by the substitution here. Let y be equal to vx. When you differentiate it with respect to x by applying the product rule, you will have it as dy by dx is equal to v plus x into dv by dx. Okay, now we'll just substitute it here. V plus x into dv by dx is equal to x plus vx divided by x. So here in this case, when I take x common, you're left with x into 1 plus v divided by x. Your x and x gets cancelled, you're left with 1 plus v. Got it? So you can write it as x into dv by dx is equal to 1 plus v. When you take it to the other side, you will have it as minus v. So here it gets cancelled. So you are left with x into dv by dx, which is equal to 1. Got it? So here it's easy for us to do it by the variable separable method now. So here you have it as x into dv by dx is equal to 1. So you have this as dv is equal to dx divided by x, because when it goes here, this also has to come here, dx by x. Now integrating it both sides. Integral of dv is equal to integral of dx by x. What is integral of dv? That's nothing but v is equal to log of mod x plus a constant. Got it? So here the third part is over here. Now what's the next part you have here? You'll have to bring it in terms of y and x. What is your v equal to here? You know your y is equal to vx. So what is your v equal to? Y by x, which is equal to log mod x plus a constant. Now when I cross multiply, you will have it as y is equal to x into log mod x plus c into x. So here if you see, this is said to be your required solution. Okay, so here this is the required solution of this homogeneous differential equation. Yes. So now we'll go over to the third question. What's the third one you get here? X minus y into dy minus of x plus y into dx is equal to 0. Got it? So you have it like this. So what's the first step you do here? I'll have to write it as dy by dx is equal to. So we'll try to bring it of that form. In other words, if you see, if you can read in your text, you will see dy by dx is equal to f of x comma y. So bring it in terms of that. So what will I get here? X minus y into dy is equal to x plus y into dx. Now when I bring this down, you have it as dy by dx is equal to x plus y by x minus y. So what is the degree of the numerator? That is also 1. What is the degree of the denominator? That is also nothing but 1. So degree of the numerator and denominator is nothing but equal to 1. Therefore, the differential equation is said to be homogeneous. So what will I put here? Y is equal to Vx. So what is your dy by dx equal to here? Dy by dx is equal to v plus x into dv by dx. This is what you have here. Got it? So substitute it here. What will I get? It's v plus x into dv by dx is equal to x plus vx divided by x minus vx, which is equal to x into 1 plus v by x into 1 minus v. So here if you see, it gets cancelled. Now here we need to separate the variables. So we write it as x into dv by dx is equal to 1 plus v by 1 minus v. Taking it to the other side, you have it as minus v. Got it? So x into dv by dx is equal to 1 plus v minus, when I multiply it, you will have it as minus v. Minus into minus is nothing but plus v square divided by 1 minus v. So here if you see, it gets cancelled. and you're left with v squared plus 1 divided by 1 minus v. Got it? So here this is what you have here. So we'll just cross multiply here. When I cross multiply, actually you have it like this, no? X into dv by dx is equal to v square plus 1 divided by 1 minus v. This is how you get. When you cross multiply here, it will be 1 minus v divided by v squared plus 1, which is equal to dx by x. That is, I am taking all the v terms to one side and the x terms to the other side. Okay. So here we have written it as 1 minus v divided by v squared plus 1 dv is equal to dx by x. This is what you have here. So integrating it, we get it as integral of 1 minus v divided by v squared plus 1 dv, which is equal to integral of dx divided by x. So here my problem, this one I can easily integrate it, because you know what is 1 by x. Integral of 1 by x is nothing but log x. Now here I have a problem here. It's integral of 1 by v squared plus 1 dv minus integral of v divided by v squared plus 1 dv, which is equal to integral of dx divided by x. Got it? So here what is integral of 1 by v squared plus 1? Actually here integral of 1 divided by x squared plus 1 dx. What is that you get here? It is equal to tan inverse of x. This is the formula. So I can write it as tan inverse of v. Here again I'll have to make use of what method here? The substitution method. So you know what is the substitution you put here? Put t is equal to v squared plus 1. You know your dt by dv is equal to 2v. dv is equal to dt divided by 2v. So you have it as v by t into dt divided by 2v. It gets cancelled, which is equal to log mod x plus a constant. So you have it as tan inverse of v minus 1 by 2 into log t, which is equal to log mod x plus a constant you get. So tan inverse of v minus 1 by 2 into log mod of, what is the value of t you get here? V square plus 1, which is equal to log mod x plus a constant. Okay. So here I have just written it as, okay, so I have just taken the LCM here. You will have it as 2 into tan inverse of v minus log mod of v squared plus 1. So you have 2 in the denominator. That 2 I have just multiplied it here. You have it as 2 log mod x plus 2 into constant. So what will I get? 2 into tan inverse of, what do you know? What is your v here? What is your v equal to here? Y by x here. So I can write it as 2 into tan inverse of y by x minus log of y squared by x squared plus 1, which is equal to 2 into log mod x plus twice a constant. Okay. So 2 into tan inverse of y by x minus log mod of y squared plus x squared divided by x squared. When I take this to the other side, you will have it as minus. Here again, by using the logarithmic power rule, this 2 it goes to the power. I can write it as log x squared, which is equal to 2c. So what will I get? 2 tan inverse of y by x. When I take the minus sign outside, it's log of, okay, so when I take the minus sign outside, you will have plus here. So you know what is a logarithmic rule here. What is log of mn? Log mn is equal to log m plus log n. This is what you have here. So you can write it as log mod of x squared plus y squared divided by x squared into x squared you get here, which is equal to 2c. Of course it gets cancelled. So what's the answer you get here? 2 into tan inverse of y by x minus log of x squared plus y squared is equal to 2c. That is the required general solution. Got it? So now the fourth question, x squared minus y squared into dx plus 2xy dy is equal to 0. Got it? So here if you see, this one actually it's not possible by the variable separable method directly. So I'll have to check whether it is said to be homogeneous. So in order to check it is said to be homogeneous, I'll just write it as dy by dx is equal to f of x comma y form actually here. So you have it as x squared minus y squared into dx is equal to minus 2xy dy you get here. So when I bring this to the denominator, it is x squared minus y squared divided by minus 2xy, which is equal to dy by dx. So what will I get? dy by dx is equal to, when I just turn it, you will have it as y squared minus x squared divided by 2xy. Okay. Now here, the degree of the numerator and the denominator. What is the degree of this? It's nothing but 2. What is the degree of the denominator? That is also equal to 2. Therefore, the differential equation is nothing but homogeneous in nature. And here, what is the substitution you will have to put here? Y is equal to Vx. So what will I get here? Your dy by dx is equal to V plus x into dv by dx. This is what you have here. Now substitute it here in this case. When you substitute it, you get it as v plus x into dv by dx, which is equal to your y is nothing but v squared x squared minus x squared divided by 2x into vx, which is equal to x squared into v squared minus 1 divided by 2vx squared. So of course it gets cancelled here. So you're left with x into dv by dx is equal to v squared minus 1 divided by 2v. When I take this to the other side, you will have it as minus v. Now when I take the LCM and simplify it, it's v squared minus 1 minus 2v squared divided by 2v. So what will you get? X into dv by dx is equal to v squared minus 2v squared is what? Minus v squared minus 1 divided by 2v you have. Okay, so here now we'll solve it by the variable separable method. We'll take v to one side and x to the other side. So when I take v to one side, what will I get? 2v divided by minus of e squared plus 1 into dv is equal to dx divided by x. This is what you have here. So now integrating it both sides. When I integrated both sides, what will I get? Integral of minus 2v divided by v squared plus 1 dv is equal to integral of dx divided by x. Got it? So here the right hand side, as usual, we don't have a problem with integration. What about the left hand side actually here? Yes, I'll have to integrate it by the method of substitution, because when you differentiate the denominator, you get the numerator. So you have it as t is equal to v squared plus 1 dt by dv is equal to 2v. What is your dv equal to here? dt divided by 2v. So it is integral of minus 2v divided by t into dt divided by 2v is equal to log x plus log c, I write here. So it gets cancelled. Now here I'll just take this minus sign here to the other side itself actually here. Okay, so I'll just write the minus sign here. So you have it as log t is equal to minus log x plus a constant. So you have it as log of v squared plus 1, which is equal to minus log x plus log c. Now what's the next step? I'll have to write my v is equal to y by x. So here we'll just write that again and then we'll simplify it and then write the general solution. So you have it as log of y squared by x squared plus 1, which is equal to minus log x plus a constant you get here. So bringing it to the other side, you get it as log of y squared plus x squared divided by x squared plus log x, which is equal to log c. So you have it as log of, what is it actually here? Your log m plus log n. What is log m plus log n actually here? It is equal to log of m into n. So how do I write here? Log of y squared plus x squared divided by x squared into x, which is equal to log of a constant. So here again it gets cancelled. Log of y squared plus x squared by x, which is equal to log c. So here when I eliminate log both sides, what will I get? Y squared plus x squared divided by x is equal to c, which implies your x squared plus y squared is nothing but equal to c into x. This is the required solution. Got it? Yes. Now here we'll go over to the fifth question here. What's the fifth question you get? X squared dy by dx is equal to x squared minus y squared 2y squared plus xy. Okay. So it's easy for us to write it as dy by dx is equal to f of x comma y. dy by dx is equal to x squared minus 2y squared plus xy divided by x squared you get here. So what is the degree of the numerator? Each term you see here, it's nothing but 2. Okay. So degree of the numerator is also 2. Degree of the denominator is also nothing but 2. So I can say that this differential equation is homogeneous in nature. So what is the working rule? First use a substitution here. Y is equal to Vx. You will get dy by dx is equal to V plus x into dv by dx you get. So when I substitute it, you have it as V plus x into dv by dx is equal to x squared minus 2 into y squared. So when I substitute it, you will have it as Vx the whole square. So it is minus 2v squared x squared plus x into Vx. What is x into Vx? Vx squared divided by x squared. So what will you have? V plus x into dv by dx is equal to x squared into 1 minus 2v squared plus v divided by x squared. So it gets cancelled here. So you have it as x into dv by dx is equal to 1 minus 2v squared plus v. When I take it to the other side, you have it as minus v. So of course it gets cancelled here. It is dv divided by 1 minus 2v squared is equal to dx divided by x. So here you have separated the variables here. What is the next step I'll have to do here? I'll have to integrate it. Okay. So So now integrating it, integral of dv divided by 1 minus 2v squared is equal to integral of dx divided by x. So here if you see, you know what is your integral of dx divided by a squared minus x squared. What is the formula you get? 1 by 2a into log of, what will I have here? It's a plus x divided by a minus x. This is a formula you have here. Okay, so using that formula, I'm going to simplify it here, integrate it. So before that, I need it as a squared minus x squared. That is, the coefficient of v squared must be 1. So I've taken 2 outside here. Integral of dv divided by 2 into 1 by 2 minus v squared, which is equal to integral of dx divided by x. So you have it as 1 by 2 into integral of dv divided by 1 by root 2 the whole squared minus v squared, because this can be written as 1 by root 2 the whole squared minus v squared, which is equal to integral of dx by x. So what will I get here? 1 by 2 into 1 by 2a. What's the value of a? It's nothing but 1 by root 2. So I can write it as 1 by 2 into 1 by root 2 log of mod 1 by root 2 plus v. It is a plus x divided by 1 by root 2 minus v, which is equal to log mod x plus a log of a constant. So here if you see, I can write it as 1 by 2 root 2, because when I cancel this, it will be nothing but root 2. So you have it as 1 by 2 root 2 log of, when I take the LCM, you will have it as 1 plus root 2v divided by root 2 divided by 1 minus root 2v divided by root 2. So your root 2 and root 2 gets cancelled. So you're left with 1 plus root 2v by 1 minus root 2v, which is equal to log mod x plus log a constant. So how do I write here? 1 by 2 root 2 log of 1 plus 2 root 2 into y by x divided by 1 minus root 2 into y by x, which is equal to log mod x plus a constant. This also I can simplify it. How do I simplify it? You will have it as x plus root 2y divided by x divided by x minus root 2y divided by x. So here if you see, it gets cancelled. You are left with 1 by 2 root 2 log of x plus root 2y divided by x minus root 2y, which is equal to log of mod x plus a log of a constant. Okay, so here this is what you have here. So this is your required solution. Got it? So here this will be your required solution for this homogeneous differential equation. Yes. Now here we'll go over to the 6th question here. X into dy minus y into dx is equal to square root of x squared plus y squared dx. So here we'll just rewrite it. X dy is equal to y dx plus square root of x squared plus y squared dx you have here. X dy is equal to, take dx outside, it's y plus square root of x squared plus y squared into dx you get. So I can write it as dy by dx is equal to y plus square root of x squared plus y squared divided by, what will I get here? X. Now check whether it is said to be of the same homogeneous or not, same degree or not. Here if you see, it is 1. When I take square root of x squared, what will be that? It will be nothing but x. So the degree will be nothing but 1 for this, 1 for this. So here the whole thing, the degree is nothing but 1. Here also the degree is 1. Therefore I can say that it is homogeneous in nature, and I can go by my method here, the working rule, by the substitution method. Y is equal to Vx. So let y be equal to Vx, dy by dx is equal to v plus x into dv by dx you get. So when I substitute it, what is that you had there actually here? You had it as dy by dx is equal to y plus square root of x squared plus y squared you get divided by x. This is what you had there. So here your y is equal to Vx plus square root of x squared plus v squared x squared divided by x. So what is that you get? V plus x into dv by dx is equal to Vx plus, when I take square root of x squared, I can just write it as x into square root of 1 plus v squared divided by x. This is what you get here. So it is x into dv by dx is equal to, when I see here, I can take x common here. So your x gets cancelled. It is v plus square root of 1 plus v squared. Taking it to the other side, you have it as minus v. V and this minus v, it gets cancelled. So you're left with x into dv by dx is equal to square root of 1 plus v squared. So by the variable separable method, what will you get? dv divided by square root of 1 plus v squared is equal to dx divided by x. This is what you have here. Now I can integrate it. Integrating it, it's integral of dv divided by square root of 1 plus v squared is equal to integral of dx divided by x. So here what is the formula I will be using here? Integral of dx divided by square root of x squared plus a squared or a squared plus x squared. What is the formula? Log of mod x plus square root of x squared plus a squared. This is the formula you have here. So how do I write here? Log mod of v plus square root of 1 plus v squared is equal to log x plus log c. Got it? So here your v is nothing but equal to y by x. Log mod of y by x plus square root of 1 plus y squared by x squared is equal to log x plus log c. So log of y by x plus, when I cross multiply it as square root of x squared plus y squared divided by square root of x squared is nothing but x, which is equal to log of cx. This is what you have here. So when I eliminate log both sides, you will have it as y plus square root of x squared plus y squared divided by x, which is equal to c into x. So what will you get? Y plus square root of x squared plus y squared. When I cross multiply, you will have it as cx squared, and this only we call it as a required solution. This is a required general solution for this homogeneous differential equation. Got it? So the seventh question, x into cos of y by x plus y into sin of y by x into y dx is equal to y into sin of y by x minus x into cos of y by x into x dy. Okay, so first step is what you'll have to write it as dy by dx is equal to f of x comma y. This is how you'll have to write here. Your dy by dx is equal to, what will I get here? So here when it is dy by dx, this goes to the numerator and this is in the denominator, and this is in the numerator. So I will write it as y into x cos of y by x plus y into sin of y by x divided by x into y sin of y by x minus x into cos of y by x. So the numerator also, if you see, it is of the same degree. The denominator is also all are of the same degree. Therefore, I can say here, what is it? It's said to be homogeneous in nature because you have it to be of the same degree here. So y is equal to vx you have here. So y is equal to vx you have here. So y is equal to vx. Now differentiating it with respect to x. So dy by dx is equal to v plus x into dv by dx you get. When I substitute it, you have it as v plus x into dv by dx, which is equal to, we'll just substitute it here, vx into x cos of vx divided by x plus vx into sin of vx divided by x divided by x into, what is your y here? Vx into sin of vx by x minus x into cos of vx divided by x. This is what you have here. So your x and x, of course, it gets cancelled here. And also I can take another x. That's what I have done here. When I take another x here, vx squared into, of course it gets cancelled. Here also it gets cancelled. Here also it gets cancelled. Here also it gets cancelled. So you'll be left with vx squared divided by x squared you have here. So you're left with cos v plus v sin v divided by v sin v minus cos v. Of course it gets cancelled here. Now we'll just multiply this here. X into dv by dx is equal to v cos v plus v squared sin v divided by v sin v minus cos v. Taking it to the other side, you have it as minus v. Got it? So you will have to subtract it. V cos v plus v squared sin v minus v into v sin v is what? Minus v squared sin v. Minus of minus will give you what? Plus v cos v divided by v sin v minus cos v. So what will happen here? This gets cancelled actually here. You're left with 2v cos v divided by v sin v minus cos v. Got it? Yes. So here we'll just cross multiply and we'll do it by the variable separable method here. X into dv by dx you have got. So when I take this, you will have it as v sin v minus cos v divided by 2v cos v is equal to, this 2 I have kept it here itself, 2 into dx by x. Now here I'll have to integrate it with respect to both sides actually, with respect to v as well as with respect to x here in the right hand side. Here you have it as v sin v minus cos v divided by v cos v dv is equal to 2 into integral of dx divided by x. This is what you have here. So here this one we'll just separate it as two separate parts here. One is v sin v divided by v cos v dv minus integral of cos v divided by v cos v dv is equal to 2 into integral of dx divided by x. So what will happen here? V gets cancelled. It is integral of tan v dv minus integral of 1 by v. So cos and cos it gets cancelled. You will be left with 1 by v dv is equal to 2 into integral of dx by x. So what is integral of tan v? That's nothing but minus log mod cos v minus log v, which is equal to 2 log mod x plus log of a constant. Got it? So here, what is the next step you will do here actually? This alone I just bring it to the other side. It's minus log c is equal to log of this becomes x squared. What is the rule you get here? Log of m power n. What is log of m power n? It is equal to n log m you get here. So here this goes to the power. It's nothing but log x squared. When I bring this to the other side, it's plus log cos v plus what will I get here? Log v. So you have this as minus log c is equal to log x squared log of mn. What is it? Log of m plus log of n. It's log v cos v you get here. So minus log c is equal to log of x squared into v cos v. Again I am using the logarithmic product rule. Log of mn is equal to log m plus log n. So it is x squared into v cos v you get. So you have it as minus log c is equal to log of x squared into what is your v here? Y by x into cos of y by x. This is what you get here. It gets cancelled. So you have it as minus log c is equal to log of xy into cos of y by x. Now when I eliminate log, you will have it as minus c of course. So minus c or plus c, it's going to be a constant actually here. So I'll just write it as some c equal to xy into cos of y by x. So here this is your required general solution for this differential equation. Okay, so here it is a general differential equation. Got it? Yes. Now here we'll go over to the 8th question here. What's the 8th question? X into dy by dx minus y plus x into sine of yx is equal to 0. So here you'll have to bring it as dy by dx is equal to f of x comma y. So x dy by dx is equal to, bringing it to the other side, it's y minus x sine of y by x. So here if you see dy by dx is equal to y minus x into sine of y by x divided by x you get here. So the degree is 1 here and here also it is 1. So it's homogeneous in nature and therefore I can use the substitution here. Y is equal to Vx where your dy by dx is equal to V plus x into dv by dx. You understood? Okay. So here it is of degree 1. Here also it is of degree 1 only here. Here it will be of degree 0 because 1, 1. Okay. It gets cancelled. So it will be of degree 0. So here in this case 0 plus 1 will be nothing but 1. So even if it's multiplication 1 1 throughout. That's why I say that it is homogeneous in nature. Got it? So here we'll go over to the next step here. It is v plus x into dv by dx is equal to, substitute it here. What will I get? Your y is replaced by vx minus x into sine of vx divided by x by x. So of course it gets cancelled. V plus x into dv by dx is equal to, when I take x common here, it is v minus, what will I get here? Sine v divided by x. X and x it gets cancelled. It's v minus sine v. Taking it to the other side, it's x dv by dx is equal to v minus sine v minus v. So here what will happen actually here? V and minus v gets cancelled. X dv by dx is equal to minus sine v you have. So dv divided by sine v is equal to minus dx divided by x by the variable separable method here. Now we'll just integrate it. When I integrate it, what will I get? Integral of dv divided by sine v is equal to minus dx by x. What is 1 by sine? I can write it as cosecant v dv, which is equal to integral of minus dx, okay, by x. Now what is integral of cosecant x actually? It's nothing but log cosecant x minus cot x. So I have written it as log mod of cosecant v minus cot v is equal to minus log x plus log of a constant. So it is log mod of cosecant v minus cot v. Taking it to the other side, it's plus log x, which is equal to log c. So what will you have? Log mod of cosecant v is nothing but y by x minus cot y by x. Here it is into x, because what is the formula you get here? Log m plus log n is nothing but equal to log of mn. So that's why I have written here, which is equal to x. So when I multiply by this, what will I get? X into, eliminating log both sides, it's x into cosecant of y by x minus x into cot of y by x, which is equal to c. Okay. So we'll just simplify it again sign here, this cosecant can be written as 1 by sine. X by sine of y by x minus x into cos of y by x by sine of y by x is equal to a constant. So when I cross multiply here, it is x minus x cos of y by x, which is equal to c into sine of y by x, and this we call it as a required general solution for this homogeneous differential equation. Correct?